Let's run through everything with question 9 in your checkup. So if we want to factor this completely, well, we need to first find the possible zeros or roots. So let's go ahead and take a look at our p, which is 5, and our q, which is 2. And so the possible roots, I'm going to call these p roots, going to equal to the possible positive or negative values of the factors of 5 divided by the factors of 2. We have positive 5 over 2 or negative 5 over 2. We have 5 over 1. We could have 1 over 2. And we could have 1 over 1. So let's simplify this list and get it in some sort of order. So we could have positive or negative 1/2, 1, 5 over 2, or 5. Great. So we could use Descartes' rule to try to find out the number of roots. Let's go ahead and do that. So if we take a look at our function, we have a positive, a negative, a positive, and a negative. That represents 1, 2, 3 sign changes, which means that we could have a possible positive number of roots of 3, which is great since we know that there are 3 total roots. Counting down, we know we could also have 1 positive root. That also could account for some complex roots. Okay, so if we had 1 positive root, no, we could possibly have 2 complex roots. We don't need to continue to use Descartes' rule to find the negative roots here because we've confirmed that we're going to either have 3 or 1 positive roots. Anyway, when we do synthetic division, it's easier to work with positive numbers. So let's go ahead and work with some positive numbers here. Let's start with the smallest. Let's start with 1/2. So to test 1/2, well, we need to put 1/2 synthetically into our polynomial function. So let's put our coefficients 2, -5, 12, -5. And so we'll bring down the 2. We should get 1. Now we get -4. We should get -2. We should get 10. Half of 10 is 5. We get 0 as our remainder. Great. So we just solve for one of our roots. We know it's 1/2. And so that can help us rewrite our c of x equation. Since we know that 1/2 is one of our roots, we can write x minus 1/2. And remember, we use our remaining terms here to write our remaining polynomial expression. And so we'll write inside of this factor 2x squared minus 4x plus 10. Awesome. So to get this in fully factored form, we need to continue to factor this here. If I try multiplying 2 times 10, I get 20, and I notice that I can't find any two numbers that multiply to 20 and add to -4, meaning that this likely cannot be factored. So another way to approach would be to try to actually solve 2x squared minus 4x plus 10 and work backwards from our roots once we find them. So if I set this equal to 0, I think the fastest way would be for me to use the quadratic formula here and solve for my x's. So I'm going to get, if I do that, this. And I'm going to speed this part of the video up since the quadratic formula should be reviewed. So now that we've found our x's, we can simply plug these in to factors. And so let's start with our first one. We have x minus 1/2. We'd already simplified that up here. Our next factor, remember, can be x minus, in parentheses, 1 plus 2i. And our second can be x minus 1 minus 2i. We're asked to write our answer in factored form, which we have since we have our 3 parentheses multiplying each other together. And remember, each of these will give us a root, which we should have a total of 3 based on the fundamental theorem of algebra. Please note that another way to write this factor right here would be 2x minus 1. Both of these parentheses will get you the same 0, which is x equals positive 1/2.